What happened to current units?
I got rid of them because I had a bug in them. They will come back when I fix that bug.
Okay.
I wanted to release this version, and I
Yeah.
didn't want to create too much confusion.
My version has it on there.
I know, but if you try to look at it, it doesn't work properly.
Yeah, I noticed.
Yeah. So I figured the easiest way to fix a problem is get rid of it.
Okay.
So, but they will come back.
That's not a problem because you just don't have the spectrum to look at.
Actually, the spectrum of the harmonics on the chord, is there any value to it or no?
Graphically, yes.
Yeah, there is.
Yes.
Okay.
Because we can look at it and say, okay, we got a lot of computer load, we got a lot of drive load, or not much drive load.
Oh, I know,
Or we
I
got
know.
some weird thing out here at 47, we need to figure out what's going
Exactly,
on.
right.
Or something, you have the zero on here too, the DC?
Yes, so you just say show the first. And
Not,
basically,
well, that's the first or the zero?
that's the first. What's the zero? Like a DC
The
now?
DC, yeah.
Actually,
There's some value to that too,
I don't display the DC.
yeah.
The reason is because I actually filtered it out at the meter section.
Okay.
Okay?
So it
It
could
will
be a
show up
future
as-
change to show that back up, right?
No. The reason why it says because the DC will actually, as a power factor, the DC component of the AC is the power factor. You
Yeah.
already have that.
Yeah.
If your power factor is not 100%, you have the DC. You can calculate it.
Well, it'd be nice to display it because sometimes there's
Well, it's
transformer
not,
issues.
It's not the harmonics though.
But it
different.
indicates sometimes other problems.
So you're telling me that the location of displaying the DC is on the zeroth order of the harmonics? Is that what other meters do?
Yeah, we'll have to talk about that.
Yeah, I didn't know that, frankly, if
Yeah,
that's the
because
case.
I don't want to get off on a tangent too
Okay.
much.
But basically, I can calculate the DC value just by the power factor.
Yeah, that's fine.
Okay, we can display that. Maybe what I'll do is I'll display it and put it on the display over here.
We'll talk about it. Yeah.
Philip, what's going on with your chart?
Where? Here?
No, the top. Is that normal?
Yeah, that's normal. That's the church.
Is that normal? That doesn't look right.
Well, that's because we got distortion in the current.
Right.
We got 3 phases of voltage and 3 phases of current.
Okay, so,
So the black ones goes with the black ones.
Are you displaying just one phase of it?
I'm sorry.
Yeah, he is.
I'm
Oh,
only
that's-
showing one phase, I can.
Yeah.
Oh, right. That's what it
Yeah.
is. Okay.
Sometimes you want to turn the others off so you can unplug the
Exactly.
page.
I got you. Okay.
Yeah.
It's much easier to understand. This is like too much.
See, his don't have much distortion,
And you do.
and we have
His are
more.
Very,
Yeah.
very nice.
Yeah.
Well,
Well, there you
on
go.
phase 3,
Yeah.
well, don't forget, there's only 2 amps. Okay, so it's really, there's not much there.
Right.
Okay.
This is 50 amps.
So when you have a shape like that with 50 amps, you have
This
a
is
problem.
the HVAC panel, so there's a lot going on there.
This is the church.
Yeah.
Well, don't forget, the peak on that is in the center of it. That means you have a special equipment that's causing that.
Exactly.
Yeah. So,
Like here. Yeah, we went over that some yesterday. But
right. So without that scope, you're not going to really know that.
Okay.
There's no other way, so that's the benefit of it. But honestly, the most important thing that you can use the scope for is to diagnose wiring problems, installation wiring problems. That's the only way to do it.
for the
because-
SP1000,
For this one.
like
Yeah.
CT
So this
rotation,
is,
position.
and I'm gonna, Connie, so this is what I was talking about the line code. This is the
Or
reason why.
bad
it's-
connection,
So
which I had in
this is the voltage for phase 2.
Okay.
This is the current for phase 2.
because of
You
your
can see
diagram on the left, your key.
There is the center point of this is a little bit after the red one.
Right.
That's what you'd like to see. That means there's a power factor, right? There's a power factor issue, but and it's lagging, which it's supposed to be. What I don't expect is the current for phase 3 to be in place of current for phase 2. I expect the current for phase 2 to be roughly around the voltage for phase 2. But when I see that the current for phase 3 is showing up where I expect the current for phase 2 to be, then it just means that the wires are twisted.
Crossed. They're crossed.
The wires are crossed. That's the reason why I said, because that's exactly what I saw when I looked at line code. You know what I mean? So, the other issue is that if I literally took this CT, and I purposely did this for this here, if I shut off phase 2 and only show you phase 1,
It's easier to see that.
okay?
Uh,
If you can see, this is what a lagging power factor looks like, right?
Yeah, we
It could
talked
either be lagging,
about that yesterday.
or I can actually have the wrong CT. This CT may not belong to this phase. Also, if I have the wire reversed, this thing will literally go upside down, right? But when it goes upside down, it looks like it belongs to another phase. So you have to try to understand, that's why you have to do one phase at a time, so there's only one available. You know what I'm saying?
So
you only
when you
do
install, you really have to install one phase at a
one
time.
phase at a time. That way
It reduces your chances of an error.
by like 90%.
Yeah.
So we need to make a note of that for installation.
Yeah, I've got that.
So you connect all three voltages.
But that means you gotta have this powered up while you're doing that.
Sure,
Yeah.
why not? I mean, if it
Yeah.
makes, how many times have you been to Lamco?
100.
You know, I mean, if you
As
just.
opposed to having a dead panel and not having to wear an arc flash suit.
Right.
and all that.
So basically, the solution is to take the laptop with you, connect it,
No,
if
I
you
mean,
want,
power
just
off
directly
now.
to it, through the, you know, the server, and just leave it there as we're wiring it, it will show it. You know what I mean? Put it in here, and you just have to capture, and that's it. I mean, every 20 seconds you get a capture for that, and you can take a look at it.
We had one of our CTs backwards, so we just turned the panel
Right,
off,
exactly.
fixed it, turned it back on, which is a little safer.
Exactly.
But not all facilities you're gonna be able to turn that off.
Well, CTs, to be honest with you, what you should do is you should put the banks in off mode, but you can disconnect and reconnect CTs, it has no effect. You can leave it
Oh,
in-
yeah, sure,
CT is
yeah.
low voltage, you can do.
Well, I'm
you can
talking
touch
about
it.
the panel, not this SP1000 box.
I
We had
understand,
the panel.
working with panel, yeah,
Yeah.
if you have to rotate, yeah.
But
it's
you can't
fine.
always do that.
Well, you can't, 99% of the time, you cannot shut the panel off.
Exactly.
Right, so you have to be careful, you have to have the gloves and all the stuff, you know, to make sure
Right.
you're safe. But in any case, that's what the benefit of, the majority of benefit comes. So I have added a couple of functions over here. One of them is the show ideal, and what it shows you is basically the ideal curve for that power factor for the phase, for the current and the voltage,
Mathematically, right?
mathematically. So
Okay.
what it does, it goes and it finds, it basically generates an artificial AC signal with the same amplitude as your actual consumption. And then it says, okay, let me go match them, find out where is the minimum error between the
In the
actual
same
one.
phase, yeah.
And then, no, there is a major benefit to that, and because of that, I'm going to put 3 more dots, check marks here, so you can only show the simulated version instead of actual one. Because simulated version has one benefit. In this case, it's easy because they look like sine waves. But in this case, okay, you can't really see where, I mean, if the current is distorted that much, you really don't know where the peak values are, okay? Because the peak values tell you basically what the real power factor is. This is the real power factor as opposed to what we measure. Power factor as we measure is truly theoretically only valid if you have a perfect sine wave. If you don't have a perfect sine wave, then exactly what frequency
How do you calculate it? You
know
don't have a
what I mean?
reference.
Imagine if your harmonics was 50%, right? Well, if it's 50%, when you say phase shift between the voltage and the current, well, which one are the currents? You have more than one current. You have current all over, right? So which one of them? So to truly find out what the true power factor is, you need to find the average wave that represents all of those waves and measure the power factor between those two phases. That's not how all the meters work. That's exactly what this one does. So this green curve represents the true average signal, and the actual power factor between them is the difference between the peak value of this. And I will display that function here.
For the displacement.
Right in here. I will actually I'm going to show a vertical line for this and a vertical line for that, and I'll actually show you the time difference between them and tell you exactly what that angle is. And the cosine of the angle is actual power, your actual power factor. No, that's not being calculated on this, on the SP1000, but it will only go for this. But then you get a true reflection of really what the true power factor is. So when you correct the system, you have a much better representation of what reality, what changed. And because when you have too much harmonics, you almost cannot make measurements. You know, but this is the way to do it. Okay, so
That will be an upgrade,
that's coming. All of it, these things are within the next month.
and they'll be able to be accessed on the web.
Exactly.
Okay,
So
good.
within the next 4 weeks, everything that I'm telling you that I
Okay,
have to
very
all
good.
get done.
Thank you.
Okay. So
And we have you recorded for that.
that's perfectly fine. One other function I have over here, this is actually the KVA. So in this case, maybe I should show it. because there's almost not much on it. So this is the actual power, and I'm sure I saw some of the presentations that you did. So this is the actual power that is being consumed on that phase, and you can see all three phases at the same time. Okay, so this is nice because first of all you can see the relativeness between the three phases in terms of power, but more importantly, if I shut this one off, anything that's below this center line is negative energy. And with a bad power factor, the negative energy is the main source of saving money. Okay, and I went through that with Philip today. In my estimation, based on everything I'm saying, 15% of the negative energy, that is, 15% of the delivery charges are due to, we can reduce, okay, maybe let me rephrase that. We can save 15% of the delivery charges that are due to negative energy.
We can say 15%.
15%.
Okay.
And when I calculated one bill that I was going over with Philip today, about 50% of the entire saving was coming from that. Okay? And that installation, we did that installation yesterday. That installation, it was a $16,000 bill per month, and we just calculated that it required one SP1000E, and the estimated saving was about $700 a month. And about $350 comes from basically the fact that you have negative energy. The power factor is 80%, and the amp draw on that was about 100 amps. And so the negative energy is substantial. And they have it all nicely broken down. Not every power company has that. That's why it showed up, because I don't get that every day,
Yeah.
where they have it actually nicely broken down. The delivery charge, demand delivery charge, KWH delivery charge, supply charge, you know what I'm saying? So because that I have it all broken down, you know exactly which one is the one that where the saving comes from. Because when you correct for the negative energy, you're essentially saving the electric company money, so that it doesn't cost them as much for delivery. Okay.
Don't charge you.
So that's one easy way to estimate your savings based on the negative energy, because it's quite a bit of it. Now, some states, some power companies, that value is a lot less. Some places in New Jersey, it's huge. It's 25% of the entire billing is just that number. You know, when you have 25% of the entire billing, one thing, and you're saving 15% of that by itself becomes 60% of your saving.
In Florida, it's about 28%.
Is it? Wow.
Sometimes even higher.
Yeah, it has been at least not the 30.
The delivery charge?
Oh,
Or the demand charges.
No, I'm
no, you're talking about delivery.
delivery charge.
Oh,
Well, there is demand delivery and then there is
no. Yeah,
consumption
'cause
delivery.
they don't break it
See,
down.
that's why I like this chart. Really,
Yeah.
Con Edison is doing it now.
Yeah,
They actually break it down. I don't see it many times. When I see it, like,
they don't break it down.
because those are the displays. Because next month I'm going to get the actual saving from this company, then I'm going to bring it in and try to make more sense out of it. 2 weeks ago, not even 2, last week, we did an installation about a month and a half ago, and last week we got the first bill, and that one there was a 14% saving. But the float meter that we put in there with the data essential was showing about 14% savings. Okay, so that was great, that we got the exact same number that Fluke was showing.
Right.
Okay, Fluke 1730 that I was showing. So now I actually have physical bill with the physical data that we did for 1 hour, and they match perfectly. I think it's a coincidence. That's too good
Yeah.
to be honest with you.
That's
I'll be happy with being within 30%. You know what I'm saying? It just happened to be the same number. And in any case, this harmonic section is pretty much self-explanatory. So I am showing the peak value, which is 0.5%. We happen to be on the 7th right here. Okay. So let me go to phase 2. Actually, yeah, let's go to phase 2 and do another capture. So it says basically waiting for trigger. One other thing that I'm going to do, when it's waiting, I'm going to clear the display, because I understand that that is a bit of a headache. Because that there's multiple phases, if you're only updating phase 1, but you already have the data for phase 2 and 3, then you're really comparing phase 2 from now to phase 3 from before. And that's a no-no. Okay, so that's a mistake. So what I'm going to do is when you say capture, erase the display, so only what you captured comes up. So, come on. And if it doesn't work, so do it again, because you may miss it, because it has a very low priority. So you might have to press that a couple of times, but eventually you will capture it. And obviously the harmonics, the worst harmonics are always at
There
lower
it is.
numbers, the third, fifth, or seventh. Okay, so wow, this one on phase 2 we have 4% harmonics, and the peak value is 0.9%.
Yeah,
So
that's-
if I show the fundamentals
that's
right
not
now,
good.
so you can see, yeah, so that's that's quite high. Okay, but the harmonics, just like everything else, it changes every time you take a sample. To truly know it, you should do it over here and do an average of, you should really do the total harmonics and do it basically, let it collect so you can see the average. Because it changes all the time.
I have a quick question. Where, the harmonics, where does the SP1000 correct? If the 60-something harmonic, where was it at?
We don't correct harmonics
I
per
mean,
se.
mitigate, word through.
Okay, let me tell you what mitigation is. Mitigation is this. If I cause the harmonic, so I measure the harmonic for basically before I turn the bank on or off, and I measure it after. Okay? If it seems like by my actuation of the capacitance, the harmonics went up, if it went up by a little bit, it's fine. But if it goes down, great. If it goes up, in other words, if it's creating resonance, then I shut it off. If the resonance is so much that the harmonic doubled, in other words, the true resonance, I physically shut all the banks off and we'll restart the reevaluation. If I just saw it went up by the exact number, I'm not sure if it's 10 or 15%, I have to look it up. Then what I do is I basically just go back to previous value of the capacitance. You know what I'm saying? If the harmonics goes up by more than 50%, I shut down the unit because I don't want to be causing harmonics. Okay? But unfortunately, as let's say you require 140 microfarad. Well, the 140 microfarad means that we don't turn all the 140 microfarad right. That will shock the system. We basically do 40, 80, 120, so until we get up to the right value. Because as you apply capacitance, the system changes. And you want to gradually go to a solution. You don't want to apply everything in one shot. Well, if one of those frequencies happen to be in resonance with the rest of the system, then you want to avoid that. And that's what we mean by mitigation. Okay? So that's basically how we deal with the harmonics. The most important thing about harmonics is that we display it. If you truly have, if you go back to this page and you find out that, you know what, 70% of all of my harmonic comes from one frequency and everything else combined is 30%, then you have a harmonic problem on that frequency. You have to do something about it. You have to go buy a harmonic filter and literally for that frequency. But you can't go buy a harmonic filter, and correct me if I'm wrong, for the 5th order, for the 7th order, for the 11th. Well, those are all individual filters. How many of them are you going to put in there? Keep it in mind, every harmonic filter has its own losses.
We talked about that.
Yeah, so I mean, if you're
Makes
losing
it too expensive.
Right. First of all, they're expensive. Secondly, you have to shut down the power. First of all, you have to identify where they're coming from. Even if you do identify it, now you have to find out exactly what harmonic filter to buy for it. So you have to make a decision.
It's much
Whether
more
it's-
expensive
Yeah.
application.
And you have to shut the power off while you're doing it, okay? Because they go in series with it. What the spider does, what SP1000 does, basically it calculates what its own effect is, and in the average, it will reduce your harmonics because it's acting like an LC filter. Okay? Basically, every time you have inductance and a capacitance, you're affecting the system. And because there is a low-pass filter, and the harmonics are naturally high frequencies, well, what happens when you put a low-pass filter on a harmonics, on a high-pass signal? You attenuate it, okay? My average calculation shows me somewhere between 0.5 to 0.75% reduction. But that's 0.5 to 0.75% kWh savings in the average. Momentarily, it might even go up, but in the average, it will come down, okay? But that's all we can do. But the benefit of that is that it's over the entire spectrum. It's not one frequency, okay? And there is no other solution. Unless you happen to have one harmonic that is so severe, maybe a motor's bearing is gone. If you have a motor bearing problem, then your third harmonics is quite high. All you have to do is go fix the bearing. But you have no idea. I was in Texas, I couldn't believe my eyes. They had so much bearing problem on this motor, their entire consumption was twice as much. And in order to solve the problem, they literally put soundproofing around the motor. Because it was so loud, they all had the headsets,
Was this motor on a drive?
this motor was actually
Just a speed drive?
no, it was not. And
See, that makes the bearing problems worse, because high frequency noise current runs through the ground, gets into the bearing, and flukes the bearing out, and then that's
well, in
causes
this case, I
failure
don't think,
quicker.
in this case, there
And
was,
then the imbalance makes that problem worse, so SP1000 would help reduce that problem.
well, let me tell you this. In this location, it was the worst I've ever seen. First of all, the motor was gigantic.
Yeah.
Okay, it was one of those car crushers. They
Oh,
literally were taking metal and chipping it, and so the currents were huge, humongous. And the motor, as a general rule, is a huge motor, and the cabling was so bad that they literally, after they installed it to them, the next day they fired the electrician. They
Wow.
were using literally on a motor, if I can recall, it was drawing something like 2,000 amps, and they were using basically a single 350 MCM cable.
ooh,
They should be using double 700 MCM.
yeah, at least.
You know what I mean? And it was 300 feet away. I mean, that cable was probably good. They had the cry cable under the ground. If you stood on top of it, probably burned your hand.
Mhm.
I mean, talk about how much power were they using. It was incredible. When basically after they fixed that, it actually made the company make money.
Wow.
Their electric bill,
Yeah, that's
just their
typical.
demand penalty was $90,000 a month. Okay, and
Crazy.
anyway, I can
Another
tell
thing
you
bad about the harmonic filter is you have to pass the fundamental to catch the harmonics. So you burn power you shouldn't have to burn. With this technology, you don't involve the fundamental. You just work on the harmonics and the power factor,
The way that it addresses harmonics is by
managing power factor.
I mean, balancing the
managing
capacitance and
reactive.
induction, right?
Yeah, managing.
Try and balance that out, too.
Which is the same thing as managing reactive power.
Managing reactive.
But, exactly. I mean, you get some inherent savings.
Right.
That's what we do. But we don't specifically have a.
You don't address the harmonics.
Exactly. We just mitigate it, make sure that we're not making it worse,
Right.
and we do basically an inherent correction for the whole thing.
Because
Okay?
you manage reactive power, it in turn helps a little bit.
Exactly. I mean, that harmonics that you see 40, right now, 2.8%, last night, it was 1.7% when I was checking that, okay? The reason was because there was very little load, so the
Well,
loads
that-
are causing it.
That's affected by what goes on in the building and what the utility's delivering to you in terms of the voltage. In
Of
other words,
course,
if you
yeah.
disconnected the building from the grid and measured the voltage distortion, you would see what your baseline voltage quality is.
Okay.
Because everybody else has got the same problem, so they're crapping the voltage out back at the substation, and that's getting spread to everybody. So,
Let's get into,
it's a big family.
Big family crowd.
so, this is the part that is most important for as far as SP1000 is concerned. This section, basically
In terms of the setup.
in terms of setup.
Yeah.
Okay, these are, I believe these are the default values, and in most cases, like Connie was saying yesterday, you have to custom make it. Well, in most cases, this is fine, it will work fine. The number one is where the CT is. You have to tell us whether the CT is before or after the panel, okay? And I was describing one condition to Philip today. It said that if you have one load on the panel that is 40–50% of your entire panel, you really should put the CTs on that load, because you're making the job of the SP1000 much harder. Because if that load turns on and off too often, then the spider will never be able to, the SP1000 will never be able to do a good job. You know what I'm saying? Because the current that goes through, if the CT is on the feed, then the current that goes through the capacitor itself is also being added. And by the big load shutting off, you basically are putting the unit into a leading power factor, and it takes a bit of time for it to recover from it. And if in that time frame the big load turns back on again, now you have a cycle you never get out of. Okay? So if the load is nicely distributed in the panel, then great, put it on the feed side. But if it looks like one or two loads are the significant part of the panel, then really what you should do is, let's say there's two of them, right? Then what you should do is you should put the CT on one of them and make the multiplier 2. You know what I mean? That would basically mean that we're responding to both of them, but at the same time we don't have that. But on the other hand, if you have 10 different breakers and each one is responsible for 5 to 15, 20%, then basically put it on the field and you okay, and that's what it's designed for to do. The problem comes in when you have one load that is substantially higher than the other one. It creates a confusion for it. So that's, and there are, on the other hand, there are locations, and I've done one, that there is no choice than to put it on the feed side, on the load side, I'm sorry. There is not a choice because they literally have panels that go far away and there's just not enough machine to put at each one, and they want to put all the machines next to the MDT, but they want to correct for each one of them individually. Then basically you put all the CTs on the load side of the system. Okay, and the supermarket that we did with 10 units, it was all like that. We couldn't even do it any other form.
It's a
Okay.
small building.
Well, small, it was probably about 200,000
Well, I mean-
square feet.
Yeah, but as opposed to a manufacturing plant,
Right.
where you gotta be more careful with the engineering.
Well,
analysis.
the thing is that in a shopping center, you have a utility room. In a
Yeah.
manufacturing plant, there is no utility room. Every room is a utility room. There's panels everywhere. Every time they install a machine, they put a panel over there. They run a cable from somewhere.
Yeah.
It's
yeah.
not like they built this factory all from scratch. I mean, from all in one shot. The factory's been there and they've been adding.
Some of
stuff
them
to
are
it.
like that, yeah, some of them are.
Well, those are the ones that we want. The one that basically they built it over time, and nobody really knows what the hell's going on.
There's a lot of
are
those.
Oh yeah, oh
That's
yeah.
a good
There's
one.
more of those, and I'm telling you, all the ones that are like that I've seen, we clear. Every month we see nice saving, 9, 10, 15, as much as 22%, because of the mess that has been created by people. You know, they have this electrician.
Hacking on the system,
What is it?
hacking on the system,
Okay.
yeah.
So, basically, those are the locations that you get the best savings. If the system.
And hospitals are notorious for that.
Oh, absolutely. Hospitals, old high schools, anything like that, that basically the business, it started a small business and expanded to a big business. Every one of
Well,
those is the best installation.
They're all the time changing something.
Yeah,
Moving your
because first
stuff
of all,
around, building
different
new buildings,
electricians
tearing
work
old
on it.
buildings down, building more.
Yeah. And they just want
Adding
something
out
that's
buildings.
correct. So that is by far the best installation. Look for businesses that started small, and hospitals, that pretty much all of them fall in that category. You know, they were never designed for what they were used for. I know Rhode Island, I'm working with Rhode Island Hospital. They basically, we made some measurement there a few months ago, and we are trying to get this deal from them. And basically, their head of engineering, one day, it was a couple of months ago, I talked to him, he said, well, we have a problem. I said, what's the problem? He said, our consumption just doubled. So what do you mean just doubled? He said, we just installed 4 new MRI machines.
Yeah.
They literally, those 4 MRIs by themselves consume just as much power than the rest of the hospital.
Because that's the way the power trend for MRIs is going.
Is that right?
Oh, yeah.
Yeah,
The doctor
that's-
wants more detail,
Right,
and
right,
that's exponential.
right.
Okay, so the machine has to work harder to give that more detail, which, quadruples the power, sometimes more.
So
The
that
MRI
becomes
machines
the
now
issue.
are water cooled instead of air cooled.
I know. In fact,
I went to the
can tell you,
factory and looked at them.
Tom Spinelli, he when he was doing this, he's been in construction business.
Yeah,
He built all this building, and he built the Yankee Stadium in Staten Island. He built it. Literally, he's a builder. And he said one of his, a friend of his, a doctor, came in and told him that he just bought an MRI machine. He wants to put it in his office, and his office was on one of the streets, like a regular street. He said, where do you want to put it? He says, my basement. The problem was that he had no basement. So he said, well, how fast do you need it? He says, well, let's put it this way. We are blocking half of the street with this machine. And, so Tom said, okay, I'll try to see what I can do. In 1 week, he literally closed down. He went to the city, got permit to close down the street for 1 week. And he literally dug the ground in the middle of the street, dug a tunnel, went under the guy's building, created for him a big basement,
There's just be
Not only-
concrete.
not
Big
only
concrete.
for him, also neighbor's basement, because the building was smaller than the MRI machine.
Jeez.
He basically built a
That's
basement.
massive construction.
He got permission from the neighbors to use their underground
Underground.
space
Wow.
as basement for this place, and he basically dug a huge hole in the middle of the street, brought down the machine, put railing, and we pushed the MRI machine and closed the whole thing back up in 1 week.
Jeez.
Guy's crazy.
That's gonna be bad when he has to change it out.
Well, it was a $2 million machine.
I know, I've
He
worked on
charged-
them, yeah.
he said-
Come on.
He charging the guy $600,000 for installation. It's not bad for 1 week of work,
Wow,
but
that's a lot.
he just